Hello everyone. So in this video again we have a very important question. So let S be a set of integers divisor of 20 to the power 9. So three numbers are chosen independently and at random with replacement from the set S and labeled as A1, A2 and A3 in the reason in the order they are chosen. The probability that A1 divides A2 and A2 divides A3 is m by n, where m and n are relative positive integers, prime integers. So find m. So it's a pretty good question pertaining to probability and also combination in general. So let's take a look at how we can go about solving this problem. So here is given basically the integers are factors of 20 to the power 9. So now let's try and understand a point here. So for 20 we have prime factors as 2 square and 5 1. So basically for 20 to the power 1 we have 5 to the power 1 and 2 square, 2 to the power 2. So basically we can actually generalize this as 20 to the power n is equal to 2 to the power twice n and 5 to the power n. Okay, so similarly for 20 to the power n we can prime factorize the same. Or 20 to the power 9 we can actually prime factorize the same as 2 to the power 18 and 5 to the power 9. Okay, now let us denote the number A1 as 2 to the power B1 into 5 to the power C1, A2 as 2 to the power B2 and 5 to the power C2, and finally A3 as 2 to the power B3 and 5 to the power C3. Now for A1 to divide A2 and A2 to divide A3, B1 has to be greater than equal to B2, greater than equal to B3, and C1 should be greater than equal to C2, greater than equal to C3. So okay, so hopefully all the things are clear as of now. So hopefully all the things are clear, and now we can actually look about trying to solve this particular questions in general. Next up, if we take a look at number of factor for 220 to the power 9, it would be 18 plus 1 into 9 plus 1. That would simply give us 190. And now if I am looking for the total probabilities, so we have here three independent numbers, being A1, A2 and A3. So therefore the total probability would be 190 cube. Okay, now one more thing, let's just look at if we add 1 to B2 and 2 to B3, we reach a stronger inequality. That is 0, B1 will be greater than B2 plus 1, B3 plus 2. This should be less than or equal to 20. Okay, because the minimum we have considered 20 space in general. So therefore we pick three integers from 0 to 20 and they will correspond to a unique solution forming a 1 minus 1 correspondence between the numbers B1, B2, 1 and B3 plus 2. Okay. This is also equivalent to applying stars and bars on distributing the power of 2. And 5 through difference. Okay, so therefore the amount of solutions to this inequality is 21 selection, a 3 selection out of 21. Okay, so now let's take a look at the other case of C1, C2 and C3. The case for C1, C2 and C3 proceeds similarly for the result of 3 selections out of 12. So therefore probability of choosing 3 such factors is 21 selection 3 and 12 selection 3, which should be given by total number 190 cube. This would basically give us 77 by 1805, where m is 77 and n is equal to 1805. 77 is the answer. So hopefully all this this particular question is clear to you, how we the approaches we have taken towards solving this. So with that said, I'm signing out. Please go through the video multiple times and try to solve it yourself with the video as a reference so that you can get a better understanding of the same. So thank you so much.